Hello students, a very warm welcome to this awesome session on capacitors. Today we are going to discuss a very interesting part of capacitors which is very practical, not only interesting, it is also a very dynamic topic from which you get few questions. You had few questions in the previous years in both JEE Mains and JEE Advanced, and these are like cakewalk questions where you could have easily scored if you had understood the concept. So today we are going to explore this concept really well, and that being given, like after this session, you should be like confident about your conceptual depth in capacitors, and you should be able to solve many JEE Mains and JEE Advanced problem. So let's get into this chapter. Not only that, as you know, capacitors are very practical topic, but we are going to explore some really very practical concept of capacitors. Okay, this is not going to be like the steady state session. It's going to be something very different than what we have been usually dealing with. And that being said, students who know me well and good, if not, I'm not. I'm Muralidharan GopalKrishnan. I completed my MS in Electrical Engineering from University of Colorado Boulder, one of the top-ranking American university in electrical engineering. And I'm also an IITian who completed my BTech from IIT Guwahati. I have 4+ years of experience preparing students for IIT JEE and other competitive exams, and I filed 25 patent applications in India and abroad. And guys, that being said, today you're going to explore this interesting topic with an electrical engineer. So stay tuned and click on that like button, and let me tell you something amazing about the channel you are on. You are on JEE English, guy, which is the nation's first channel where you get your IIT JEE lectures from basics until advanced on this in exclusively and completely in English. And guys, do not forget to click that subscribe button and bell notification to get this timely updates. And that being said, students, you can check out our Telegram channel to get all the timely updates on what is happening every day on JEE English channel. Can be anything from from previous year question paper discussion to like special classes that happens on Sunday and Saturday, or any classes that is happening on Unacademy learning app. You will get all the notifications on any lectures conducted by lecturers on this channel. So click on to that link. It is available in the description box. First of all, you need to download the Telegram app. If you haven't, do download the Telegram app and click on to the link available in the description box. Else, if you're already on Telegram, if you're looking for a shortcut to get onto this channel, just type in JE_English, and there you will go and get all the updates. Hi Renu, hi Vinay. Yeah, Vinay, you'll get the PDF notes soon. No, Renu, it is at 7:30. Good evening, Roshan. I'm really very sorry. The session was supposed to be at 7:30. I mean, there was some, like technical errors while hosting the video. So I'm really very sorry, students, for this inconvenience. Like the the lecture was supposed to commence at 7:30, but unfortunately, I guess it has been there was some technical issues. So that being said, guys, let's get into this awesome part of good evening, students. So if you haven't completed yet the lecture on the color coding of resistors, do go and complete it, because it is a very interesting part. Not only that, it's very easy, guys. And we discussed anywhere around 5 or 6 JEE Mains question, that too on the JEE Mains 2019 question in this session. It was conducted on 31st of August, but do not miss out the session. It's easy. It's easy means very easy. The easiest topic that you would see in on physics, but at the same time you got anywhere around 5 questions altogether combined in your 2019 JEE Mains paper. So do not miss out the session. And to attend these kind of sessions, you need to download Unacademy learning app. So how do you do that? You need to just search Unacademy on your Google Play Store and App Store, and the first search result is going to be Unacademy learning app. Good evening, and that being said, guys, what do you need to do to after you search for it, you click on that install button. That's all you need to do, students. And stay focused, do not get distracted throughout the session and also during your JEE preparation. And that being said, guys, if you need an awesome tool for your JEE preparation, a complete package that comes with all the things that is necessary for your JEE preparation, that is available with Unacademy. And what you get in that? You get access to live test series, time test, something that you need for your JEE preparation. And also, students, you get access to systematic learning with live quizzes, also daily interactive sessions with your favorite educator, and also doubt clearing sessions with them. And that being said, students, how do you avail this, like this tech-based platform? So what am I saying? Why am I saying this tech-based platform? So it's equipped with the state-of-the-art technology that puts you into that environment like what you're doing in your exams. So how do you avail this platform, and what is the specialty is what we have discussed. But how do you avail this platform? So you need to click onto the extension bar and click on that first icon, and then be sure to choose your goal as IIT JEE, because your preparation will be like planned according to that. If you're choosing IIT JEE, your preparation will be planned for your IIT JEE Advanced and IIT JEE Mains preparation. And that being said, after you choose your goal, get your subscription, guys. Be sure about your target, students. Never get discouraged, never get demotivated. That is very, very important, that you never stay demotivated, be it during any of the topics. If you know it well and good, but make sure you understand each and every part of what you're learning. And also, if you are already on subscription platform, go and attend the test series, because they're very important, guys. Time tests are very important. I mean, you get all the concepts for free of cost on many Unacademy channel, and for JEE preparation, you get it on JEE English. But students, do remember, you need to practice tests. That is very, very, very important, students. So that being said, and also get your doubts cleared on time. And that being said, right now the prices are low, students. So do not forget to get the subscription right now. If you're planning to get the subscription, get it right now. And the 24-month subscription is only 1,500. So it's a very economical package for the kind of things that you get, like all this, perks and benefits with 6,000 plus materials for your JEE preparation. And this is near about only 1,500 rupees. And you can again apply Murli Live coupon to get a 10% additional discount even on this purchase. And that being said, like, you can also go for like a 12-month subscription if you're a long term or dropout. But if you're in 9th class, or 10th class or 11th class, and you started for your JEE preparation just now, do avail the 2-year subscription, because it's at least a 2-year long journey. Yes, of course, you can do it in 1 year if you're in long term or dropout. Then you would go for like a 12-month subscription, which is going to cost you 2,500 per month. And that being said, guys, this 2,500 per month, again, you can apply Murli Live coupon to get a 10% additional discount even on this price. Yes, Vinay, notes will be available. And Roshan, current and electricity is completed. Okay. So you can apply this Murli Live coupon to get a 10% instant discount on this purchase. Even this is also very economical. You know that these prices are like very super, economical for your JEE preparation, and it's quality, guys. It's quality, be it your free lectures or be it your paid subscription that comes with all the things that is necessary for your JEE preparation. It's like the state of the art technology that we continuously, maintain on our platform. And guys, not only that, it's only one subscription and unlimited access for the time period that you avail it. So make sure you avail it early, because the prices are going to be hiked from 10th of September onwards. And do not forget to apply the Murli Live coupon to get the discount. So hurry up, students, especially 11th standard students. Try to get it on time, because if the subscription prices are going to be hiked, comparatively a lot compared to what it was before. I mean, a lot in a sense, still it's not a lot, but make sure you get it on time, because you don't want to pay the extra price for the same like the kind of platform and the kind of package that you're going to get. So now, if you are going for like a 2-year subscription, in total it's going to cost you 32,400 after you apply Murli Live coupon. But if you're going after 10th of September, it's going to be 50,400 odd. Okay, anywhere around 18,000 hike in the prices. That's a lot, guys, even after applying Murli Live coupon. So do not forget to apply the coupon at the same time, guys. Get it early so that you can avail the subscription. Start early, students. Don't wait for the time to pass. And that being said, be focused on your goal. You should be focused on your goal, and do not focus on your obstacles. You should only try to overcome the obstacles, understand the obstacles, and try to crack the obstacles. And guys, do stay motivated throughout the session, or beat any session. It's a very interesting topic, guys, and you are on one of the Unacademy's platform, which is impacting near about 7 million lives a day. So don't forget that you should be focused on your target. You are on a very ambitious platform, and students, I hope you are also very ambitious. Stay focused on your target, stay focused on your dreams, have some dreams and goals, set your target, guys. You want to get into one of those awesome IITs and NITs, you want to enjoy those, everything that is available over there, be it your recreational facilities or be it your research facilities, and the kind of faculty that you want, and also the brand reputation that you get along with the colleges. So have the dream in your mind and start early. The key to success is not to focus on the obstacles and worry about the obstacles, but rather to focus on your target, dreams, and goals. So stay focused. So let's get started on this topic, guys. Roshan, I'll get back to you. And that being said, students, when we're talking about charging and discharging of capacitor, this is like like a small simulation on charging and discharging of capacitor. Initially, we are attaching the switch over this position, and this position charges the capacitor, and this position discharges the capacitor. Okay, so if you've noticed, this is like a dynamic simulation where you're seeing the capacitor is initially getting charged. I mean, it's like getting charged like with time, step by step. But in reality, the capacitor is never getting actually fully charged. Okay, so capacitor, like when you're talking about steady state, or whenever you come across a problem in your exam regarding steady state, that says like, okay, the capacitor is already fully charged. But practically speaking, you can never fully charge a capacitor. So let's understand why and how does this work, and like, can current flow through capacitor? So that is one of these questions that must be in your mind. So make sure you understand each and every part of what we are going to discuss today, because it's a very important topic, and as well as you can get some questions in your JEE Mains and Advanced. So we are also going to discuss some of those questions that came earlier in your JEE Mains and Advanced. And that being said, guys, let's first of all understand the charging of the capacitors. So what do I mean by charging? So you need to charge the capacitors. Let's say initially this capacitor was not charged. The potential difference across the plates is zero, no charge polarization. And let's say you just press this switch, or you attach this switch to this point, and it is joined. So initially what happens is, unlike what we have read in the steady state, practically capacitors do not get charged. So how they would really get charged is over some period of time. That's a very short period of time. I mean, like within like a fewer milliseconds, would actually get to its 99.9% charging potential, or 99.9% of the energy it can store. So that being said, once you close the switch, the capacitor will begin charging. It start accumulating the charges until it attains that steady state. So we are today going to study from from that part where you are going to tap that key or push that switch, and like the current flows through capacitor, guys. Okay, so one of the most interesting thing that you should know, in fact there was a JEE advanced question on this. So at time t is equal to 0 is when, let's say, we are just switching it on, or tapping on the switch. So what happens is, at that time, this capacitor acts like an closed circuit. Sorry, guys. So it acts like a short circuit, closed short circuit. So what do I mean by short circuit? So uh, as soon as you are tapping the key, this capacitor is going to really not have any potential across it. So what was happening in steady state? Let's say we are analyzing in steady state. So in steady state, capacitor was actually developing the potential in the opposite polarization direction to that of battery. So in steady state, the capacitor would have developed something like V across it, this capacitor over here. So let's say after some long time, it has developed V across it. So at that time, what is happening is capacitor is acting like an open circuit. Okay, whereas once at time t is equal to 0, so aptly said, not close, this very confusing. At time t is equal to 0, it is acting like a short circuit. Okay, so this is very important. So as soon as you tap the key at time t is equal to 0, there is no potential across it. So when the potential is 0, so it is going to act like a short circuit. Okay, and capacitance potential would be 0. And at t time, when it tends to infinite, we say that infinite, but you'll notice that within short time it will almost get to that 99.99% of its charge, and it's going to reach something known as steady state, where it would behave like a open circuit. Very important concept, guys. Very important concept. Okay, so it's going to behave like an open circuit. And what would be the potential in this case? I mean, in the specific case, DC would be equal to the EMF potential. Okay, I hope this is clear. Yeah, we'll do some questions, Roshan. Hi, Rohit. Good to have you. Hi, Renu. Hi, everyone. So stay focused and try to absorb and grasp the concept as closely as possible. So once you close the switch, the capacitor will begin charging and will start accumulating charges until it attains the steady state. Steady state is something like practically speaking, your capacitor is going to be like 99.99999% charged after some, depending upon the resistor as well. So your capacitor, how it is going to get charged, it is going to also depend upon this resistor in this combination. But after some, a long time, what is going to happen is this capacitor is going to behave like a open circuit. Okay, so it would attain all the potential. So if you apply loop law, you will come to know that this capacitor is stopping any current flow. Earlier, when we just began with switching on the circuit, what happened was the capacitor was behaving like a short circuit. What happened between this time is our like the question in our mind. So what is happening between this time? So what is really happening between this time and how is this capacitor getting charged? Is it getting charged uniformly or it is getting charged very quickly and after a certain time it is not able to charge? So let's understand it, and let's first of all, let's take, as a time t is equal to 0, capacitor at no potential, and I'm going to call Q as the charge across capacitor was 0. Very simple. And now what happens is, let's assume a time t, some time at time t. Now this capacitor is going to develop some charge. Okay, let's say it has accumulated some charge, Q, and if it has accumulated some charge Q, it has also developed a potential across it. How much is the potential? We're just analyzing the time at time t. What is happening? One is it is accumulated charge. Two is it has developed some potential across. And how much would that be? Q by C. All right, really simple. Now, if it has accumulated Q by C charge, so initially the entire, what was the initial current, guys? Initial current was, let's say we are going to analyze the current. In the initial stages, there was some current across it, right? Because it was like a short circuit. So then the current was something like I is equal to entire VMF by R. All right. At a time t is equal to 0, it was entire EMF by R. At time t, like at some time t is equal to t. Okay, what is happening then? At some time, okay, at some time after that initial state, let's just not, we are not talking about steady state, we are talking about the time between which it is getting charged. So now what is happening is the current would not be V by R. Okay, so if you go through this loop, there is a Q by C potential drop across capacitor. So now the current would really become I at some time t. Now it's not V by R, but rather V minus Q by C by R. All right. So now you understood this part. Now, what is this? There is a relation between this I and Q. I can be written as dq by dt. Can we? Yes, we can. And it is a function of the change in charges on the capacitor. And that being said, this is Cv, where V is the entire potential, guys. Okay, not on the capacitor. We know the capacitor is Q by C. Okay. Now this is going to be Cv minus Q by R. All right. Rc. Okay. Cv minus Q by Rc. Now you are going to integrate it. Okay. Let's see what happens after we integrate. So we got this expression dq by dt is equal to what was that we got? Cv. Cv would be the potential across the capacitor in steady state, minus that would be the charge on the capacitor in steady state, minus the Q that it has accumulated right now, and by Rc. So from here you understood that if I'm saying this is the dq by dt, what is dq by dt at steady state? At some t tends to infinite is what we are saying, but it's not really infinite. What is going to happen? Your dq by dt is going to be 0. You got that point because Q is equal to Cv. Now let's analyze for some time t. That is where we began our analysis, right? So let's analyze for some time t. I'm going to carry out this and this expression and integrate it. All right. Just before that, we need to work around some math. Vc is equal to Coulomb by charge. I didn't get your question, Roshan. What's your question? Vc is not. No, Vc is potential across the capacitor. Okay. So that being said, guys, so yes, here it is actually Vc and V are equal at steady state. Okay. So now we're going to do this dq by Cv minus Q is equal to dt by Rc. All mathematical, guys, but there are a few things that you need to understand. You need to understand this concept because if you have got some combination of resistors, you need to do this process. Okay, there are some shortcuts for few of that like combination, but frankly speaking, if you are so no one is going to ask you a direct question in your JEE Mains or JEE. Probably you have some resistor combination and you would have to derive that time constant, or let's understand what is the time constant and etc. First of all, let's now analyze how to get this result. Okay, and how to really we are actually analyzing what is this charge accumulation across this capacitor going to be at the moment. Okay, so I'm going to say I'm going to integrate this dq from some 0. It started at 0 until some q, and it reached that q at some time t. Started at 0 and it reached the time t. So t is when switch was t is equal to 0 is when just switch was closed. It's a very interesting concept, guys, and it's actually very practical. When you're designing your circuits, especially you'll be dealing with DC circuits, and then you need to understand this concept really closely. Okay, how do you integrate this? This you get a minus sign, right? This is Cv minus Q. You take this entire thing as x, and then what is this dx going to be? Dx is going to be minus of dx. Okay, dq is going to be minus of dx. That way you would get something like this. This is going to be log Cv minus Q is equal to T by Rc. All right. Yeah, moving forward, you'll understand like how to solve even for different resistor combination. For now, Roshan, focus on the class. Stay attentive throughout the class. Try to take the notes. Even though if you're not interested in the derivation part, do the derivation along with me, students. It's very important. And also share this video and ask your friends to come on board. It's also very important that many students do come to this channel and they get access to this channel. And try to derive it along with me, students. Try to derive it along with me. You don't want to spend your time again on derivation. Maybe again you go home back and do it. I mean, like after the session you do it again once more. Okay. That being said, this is going to go from this is going to go from 0 to q, and this is going to go from 0 to t. You have integrated the thing, and there should be a minus sign. All right. So this minus, you can take it that side, and let's do the integration part. I mean, we need to just substitute 0 and q. It's going to be ln CV. ln is natural logarithm minus q. I'm taking that minus on the other side. Minus of ln CV. I've substituted q is equal to 0 in this part, and this is minus t by rc. T minus of 0, 0 you don't care, it's just t. Minus has been carried over here. Okay, so you got this minus sign over here. So now you know what to do when it is ln a minus ln b. You can write it as ln a by b. If you're not aware of this, well and good. If you're aware of this, awesome. If you're not aware of this, this is how it would, this is how log works. Okay. So that being said, the earlier expression, I'm just directly going to write it down as CV minus Q by CV is equal to minus T by RC. What is the time? We are actually determining the time and the charge relation. Okay. So from this relation, if you substitute for some time T, the value of resistance and the value of capacitance, you will get the charge that would have accumulated on this capacitor. All right. So that being said, you know what to do. I'm taking exponential on both sides. So this itself gave you some, indication like how this entire circuit, this charging is going to happen. Some exponential relation exists, and that exponential result is going to be very, very interesting. So this you take 1 minus Q by CV. So given any circuit, you do the same thing. You will analyze the current. So again, I'm explaining to students before we move to the that part of it, that part of charging and discharging of capacitor. So what did we do? We analyzed the current. We know in this case, we analyzed what is going to be the charge at some time t. We took it as q, and the time t is t, and we analyzed the current. From that current, expression, we are getting to the relationship between the charge accumulation on this capacitor C and at time t what it will be from compared to its final charge that should have accumulated on it. Okay. That being said, so this is going to be e power minus t by rc. So you further simplify this, you will understand. This is nothing but q is equal to you take it this side, you take this one this side, and it will be multiplied by c into v into 1 minus. And also one more thing, students. So few values will not be given to you in exam, because it is assumed that while you are doing your practice sessions, or while you're learning the session, you're probably also practicing problems, and those values would be 1 by e and 1 by e. So 1 by e you have to remember this, and also how to convert log 10 to log from log natural to log 10. Okay. So these are two things that you need to remember while you are working on this, this kind of problem. Okay, writing 1 T by RC. Okay, this again. So derivation is that simple, but do remember this is not a derivation. We are actually deriving the relation. This relation is going to be critical throughout your understanding. So all these concepts that we have discussed until now is very critical, guys. Okay, so from this we can analyze few things. At time, substitute time t is equal to 0. Yeah, Jay Akash, yes, I do. Hi, Jay Akash. So focus on the class, guys. So that being said, for time t is equal to 0, what is the charge on it? Substitute this thing time at time t is equal to 0. Substitute in this expression 0 to the power something, that's going to be 1. 1 minus 1, that is going to be 0. All right. And again, if I'm going to say substitute, t is equal to infinite, it's 1 minus of 1 by e to the power infinite, that is going to be 0. This e to the power infinite, that is nothing but 1 itself. So you're going to get something like CV. So is that the steady state? When t approaches infinity, it is going to be steady state. Q is equal to CV. All right. So this is all about charging of capacitor when we are only talking about one resistor or this simple combination of resistor. And that being said, now I'm going to say I know that the maximum charge on the capacitor is going to be CV at steady state, and I'm substituting that CV is nothing but Q naught. Okay, and there is something interesting about this RC. Not just in only DC circuits, also in AC it is very interesting part. But now we are dealing with DC, guys. Okay, we'll be focusing on DC. So I'm going to call this as tau, which is known as time constant, students. Okay, so this tau is nothing but time constant. All right, you should remember this. They would not tell you RC, they would talk about time constant. In fact, if you have noticed your previous year JEE Mains and JEE advanced questions, it was only stated as time constant. And what is the significance of this time constant tau? So, at tau, at time t is equal to tau, there is a significance of this tau. So, we are not simply saying this is tau. This capacitor is 67% charged. All right. That is good if you memorized it, but don't memorize it, Jayaka. Yes, derivation is important. More than like how we came to that expression is very important, Jayaka. Because as we move to the lecture, you will understand that some part of derivation is what we'll be using to solve many problems. Okay. Initial problems will be very simple, guys. So we'll be solving. We'll be dealing with anywhere around 15 different kind of problems on this chapter. I mean, like in this session itself. But at the same time, do remember that some of these problems are going to be dependent upon this concept that we are deriving right now. Derivation is important. I can't simply tell you this e to the power q is equal to q naught is equal to 1 minus e to the power t by tau. Okay. If I've told you this, then I would have to explain tau, I would have to explain q naught, and just substitute and show you. But when it comes to problem, maybe we don't understand what is happening. All right. So substitute this t is equal to tau. What it is? Q naught into 1 minus e to the power tau will get cancelled, and e power minus 1 is nothing but 0.37. Okay. So you have to remember few things, guys. So 1 is e to the power minus 1 is 0.37. In this chapter, you have to remember this. Okay, I'll tell you a few things that you need to remember, because I also noticed your previous year questions and these things were not given explicitly. It generally does not happen in your JEE advanced, but in JEE Mains, of course, expect something, like they are not going to give you even logarithm conversion. First, it is expected that you have already solved problems and you know it. Okay, so yes, e to the power minus 1 is going to be 0.37. And that being said, how much this would give you? 0.67 of Q naught. That means your capacitor is 67% charged at time t is equal to RC, or at time t is equal to tau. A very important part, students. Yeah, there will be many questions just formula based. Yes, but also the thing is you have to Good question, Jay Akash, and good that you reminded me. So yes, students, you have to remember this. You have to remember the graphs. You have to remember few things in this chapter. But there is nothing to remember. Okay, you know this how to remember this expression. Okay, Q naught is the maximum charge that is going to be accumulated on it. So it's going to be C into V, where V is the battery connected to it, and is the EMF of the battery connected to it. And what is tau? RC. And how do you know this is the charging expression? At time t is equal to 0, q is equal to 0. You will get it as q is equal to 0. At time t is equal to tau, you should get 67%. Verify whether you are getting 67%. And at time t tends to infinite, you should get q is equal to q naught. So verify these things. This is some way if you have some confusion remembering this, but I guess you should not have after this lecture, guys. So that is the significance of your, the tau, this time constant. This is popularly, called as time constant. So you have to remember this thing. This is known as time constant. You have to remember that expression, and you have to also understand the graph if you have been plotting it. Okay. So yes. So that being said, this I'm writing it as Vc is equal to V naught. How did I get that? I simply what did I do? I had this expression, right? Q is equal to Q naught 1 minus e to the power minus t by tau. In this expression, what did I do is really, just a moment, just showing you what happened over there. So you basically derive the potential from that earlier expression. Q is equal to Q naught into 1 minus e to the power minus t by tau. In this expression, what we really did was this, q by c. You do that, you will get the answer. Okay, q naught by c is nothing but cv itself. So if I divide on both sides by c, I can call this as, at some time t, this is going to be the potential across the capacitor. Okay, at some time t, this is going to be the potential across capacitor. Try to understand what we are discussing in the graph, guys. Very important. Few questions, very simple cakewalks. You will get it based on this graphs. Okay, you don't want to ever miss out the cakewalk. So that is going to be how much? CV divided by C. That's going to give you V, and that's going to be 1 minus e to the power, exponential minus t by tau. All right. This can be also given in exams like exponential. So just introducing to the basic things that you would expect. So that is what is being written over here. So we are actually in this graph, we are analyzing what is the potential difference that is being developed across the capacitor. So as I told you, this is like the exact values, like 63.2% of the voltage is being developed at time t is equal to tau. At time t is equal to 2 tau, you have anywhere around 86.5%. Okay, and at time t is equal to 3 tau, you have anywhere around 95%. Are you noticing something? When until it was like tau 63% had reached, but again the time difference between these both is only tau. Time interval between these both is only tau. Time interval between these both is only tau. Time interval between these both is only tau. Okay, but here just for that anywhere around 3.2% of charge at time t is equal to 4 tau, you have anywhere around 98.2% of charge accumulated on the capacitor, or the capacitor is charged to its 98.2%. Whereas if you have noticed this, it only increased by 3.2% within that tau. Whereas initially from 0 to tau, this thing has reached 63%. Okay, this thing has reached 63%, then it was 86.5%, then it was 95%. And it keeps on reducing. The tau, this keeps on reducing. All right. So that is the main thing. And do remember, at 4 tau it reaches anywhere around 98.5%, 98.2%, and at 5 tau we generally call it as a steady state. Okay, not necessarily, but generally this is the steady state, because as such at infinite is when it will reach the maximum potential, but at steady state it has almost attained 99 point some percentage of its energy that it can store, or 99 percentage of the charge it can store. So we are going to call this t is equal to pi tau as that, steady state period. Okay, so this will help you solve many problems in your exams. Like you don't have to exactly remember what is happening at 1 tau, 2 tau, 3 tau, and 2 tau, and tau. You have to remember at tau it gets to 63%, at 5 tau it gets to anywhere around 99%, and at 4 tau it is near about 98%. I mean near about 99%, 98.2%. So these are few values that you have to remember. May not be what happens at 2 tau, what happens at 3 tau, but I've told you how to derive for it. 1 by E is going to be 0.37. If I'd asked you to take a square or something, you can do that. Alright. So substitute T is equal to 2 tau, it would be 1 by E whole square, right? So you can do that. Okay. So that way your capacitor reaches steady state at near about 5 tau. Or something, right? So that period is generally known as, until it reaches that steady state, it is known as that transient period, for which takes that 5 tau amount of time to reach the steady state. Okay, you notice this is known as transient period. The stated at 4 tau, near about 5 tau is when you call it at steady state, but it's few milliseconds. But notice that it's exponentially increasing, and then it takes like at least another 4 tau to reach the steady state, anywhere around to just increase half of this potential. This is 63%. Okay, like more than a little off, but yes. And you can also derive for what is when it is going to be 0.5 of the total potential that it will develop, I mean max potential that will develop across. So one more thing is we have spoke about we have discussed about the charge. Now how would the current on the resistor? The current on the resistor is going to decrease, whereas the charge on the capacitor is going to increase with time. Okay, I'm going to call this as current across the resistor. How do I derive this? I'll simply differentiate this equation and derive it. That's it. And that being said, do remember guys, in charging of capacitor, what is happening? The charge will keep on increasing across the capacitor, and the current will keep on decreasing across the capacitor and resistor. Okay, to differentiate this, to find out the time, dq by dt, I'm just directly writing down as I, and dq naught by dt. First term is going to be dq naught by dt. I don't care about it, and I'm going to, because that's going to be 0. And next term is going to be q naught t e to the power t by tau. So I'm going to get something like minus 1 by tau, and that's going to be e to the power tau itself. And if you remember, the expression of q naught tau will get something what you are expected. What is q naught? C B. What is your tau? R C. And e to the power t by tau. It's basically v by r. I is equal to v by r e to the power t by tau. Alright, so that being said, what is the current across the resistor and capacitor at time t is equal to 0? So let's analyze something like what we analyzed before. So if I told you at time t is equal to 0, what is the current? E to the power 0, that's going to be 1, I is equal to V by R. And at time t tends to infinity, some large value, that means it is going to be something like 0. At steady state, current is going to be 0. You know that point. And initially the current was maximum, V by R. So your capacitor did really act like a short circuit at time t is equal to 0. Got it? So you understood this point. All right. I think now everything is clear, and now I'm going to write down this, as I is equal to I naught, of course, and I naught will not be explicitly told to you, but you know what is that I naught. Okay, and you know what is the tau as well. So the thing is, if you are noticing, the current is decreasing with time. Okay, the current across the capacitor IC is decreasing with time. It reaches at t is equal to tau. How much is the current across capacitor? 37% of the initial one. All right. So at t is equal to tau, the current across the capacitor is 37% or 0.37 times of the initial current. There is nothing but V by R, right? So these are some important points, students. Okay. Any conceptual question, any assertion, reasoning question, you should be able to do it. Hi Vaishnavi. Hi. How are you? So yes. So that being said, students, do try to understand this point. The current is decreasing while charging the capacitor because your capacitor is developing a potential across it, right? Which is going to counteract the potential due to the potential difference due to the EMF from that, due to the battery, and the current that way is decreasing. But with time, how is that potential across capacitor increasing? Because the charge accumulation is increasing, and at near about 5 tau, the current should become near about 0. Okay, at 5 tau, the current would become near about 0, but um, you can you understand it, like near about 0, not really 0. Okay. So yes, theoretically it never becomes 0, and theoretically the charge is never fully accumulated. Okay, and do remember this expression, students. I brought this expression, and I get that, and you got that. We are going to enter the problem. So log ex, you convert it into log 10x by 2.303 is the conversion factor. Okay. Few things I told you to remember: the expression of Q is equal to Q naught 1 into brackets 1 minus e to the power t by tau. Q naught is nothing but CV, where V is the potential difference or the EMF of the battery, and tau is equal to RC. The other thing was 1 by E is equal to 0.37. And what is tau? Tau is when your capacitor, in terms of charging, tau is when the capacitor gets 67% of its total charge that it can accumulate across it using the same kind of battery with the same kind of potential difference. And this conversion factor is something again you have to know. Okay, 2.303 log 10 of x. Okay, yes, let's move on and let's get started with some interesting questions on this topic, guys. Okay, so if you remember everything, it's a very easy question. So capacitor of 100 microfarad is charged, by connecting it to a battery of 12 millivolts. Sorry, 12 volts, I guess. And with a 12, 2 ohms resistance. So a capacitor of 100 microfarad is charged by connecting it to a battery of 12 volts and internal resistance of 2 ohms. Find the time constant of the circuit. It is simple, isn't it? What should be the time constant in this case? Awesome, Vaishnavi. Yes, it's 400. That's correct. Oh, no, 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 no. Not 400, right, Vaishnavi? What is it? So what is the value of R? R is 2 ohms. and C is 100 microfarad. Guys, this is a simple one. Time, and one more thing, students. What is the units of RC? Seconds. What is the unit of your tau? Your tau is in seconds. Okay. So 2 into 100, that's going to be 200 microseconds. All right. It will be 200 microseconds. Okay. So yes, one more important thing, guys. So this is something that we should understand. How did we get to that unit? If I'm telling you, RC is directly just this, the unit is seconds. You can actually derive it. Let's do that. So RC, and let's do the dimensional analysis. Resistance, you can write it down as from V is equal to IR. I will write it down as R is equal to V by I. And what about C? C is equal to Q is equal to CV. This would be Q by V. Okay, just try to calculate what is RC. RC is nothing but you multiply them. We are just doing dimensional analysis, so don't worry about what we are doing. This is just dimensional analysis. Dimensional analysis. We are doing dimensional analysis of RC circuit. Sorry, RC, and that is going to be Q by V. All right. And what is this? dq by dt. So I'm just doing dimensional analysis, so just writing down coulombs by time. That will be time. All right. So that is it. Yes. So this way you understood the dimension. Yes, Vaishnavi. So dimension is time, which is nothing but seconds. So RC gives you seconds. Okay. So there is no doubt in this. This was something that we should have explored. And tau is also, tau's unit is also seconds, guys. Okay. So you can actually, calculate it in terms of ohms, and ohms and farads multiplied would give you seconds. And that being said, also tau's unit is seconds. All right. So let's move on then. Let's move on to a very interesting problem now. So yes, students, it's being asked a capacitor of capacitance 100 microfarad. Sorry, just a moment. So a capacitor of capacitance 100 microfarad is charged by connecting it to a battery of EMF 12 volts and internal resistance 2 ohms. Find the time taken for its charging the capacitor until 99%. We are going to do so given options are like 200 microseconds, 420 microseconds, 630 microseconds, 920 microseconds. So which among this should be the answer? So we did some graph. You can analyze this from the graph. If you understood that graph, we spoke about few things, when it is going to attain the steady state, and when it is going to get 98.6% charged, 98.2% charged, and when it is 67% charged. Vaishnavi. So yes, okay. I think there's no space over there. So how do we do this? You have to only analyze the option. Like what you do now is you remember a few things. One is it is going to be 98.2% charged at about like 4 tau, and it is going to be near about some 99 point some percentage charged at 5 tau. So your answer should lie between 4 tau and 5 tau. Yes, Jay, yes. So that being said, what is tau in this case? We just calculated tau is 200 microseconds. RC. And what is that value? So what is 4 tau? 4 tau is 800 microseconds. And so you can actually notice that to reach from 98.2 percentage to the 99 percentage, how much time it is taking. So that is going to be 1000 microseconds, so anywhere around 1 millisecond. Okay. So if you have noticed this point, guys, if you have noticed this thing alone, you understood that these three are not the options. 200 microseconds, it's only 67 percentage of its total. Near about 400 microseconds, it's going to be charged anywhere around 86 percentage or not. So this is also not your answer. 630, it is going to be anywhere around 90 percentage and not charged. Not really. No, it's not going to reach the 99. So it should be 920 microseconds. But a very interesting fact to reach that 67 percentage. Okay, this should be 63, guys. Sorry. This should be 63 percentage. 1 by 0.37. Yes, this should be 63 percentage. And do remember this point, students. Like to reach, 99 percentage, it's taking 920 microseconds. A very small, number. But to reach 63 percentage, it only took 200 microseconds, more than 4 times. More than 4 times, what is the time required to charge it from 63 to 99%? Right? So actually, near about 4 point something like 4 point some 5 4.5 4.51 times or something like that. So it's a lot of time compared to what it took to charge until 63 percentage. Lot of time to reach that 920 microseconds, to reach that 99%. Very interesting, guys. It's a very interesting thing. So it's a JEE Mains problem, students. Why don't you get started on this and how to solve this problem? Okay. So given to you a resistor R. Read the question. Take your time. Read the question. Try to answer this correctly. Like you will get started on this, and you take your couple of seconds to read the question, and then you like around 15-20 seconds is how much you should take to read the question. It's a pretty lengthy question, I guess. Resistor of resistance R and a capacitor of 2 microfarad is connected in series to a 200 volt direct supply. Across the circuit is connected, across the capacitor is connected a neon bulb that lights up at 120 volts. Calculate the value of R to make the bulb light up at 5 seconds after the switch has been closed. The diagram is not explicitly given to you, but it is told to you theoretically what is being happening in this case. Okay. So the question is saying there is a resistor R and a 2 microfarad capacitor connected in series to a 200 volt direct supply. Okay, and across them is connected a neon bulb. Okay, and that lights up at 120 volts. Okay, across the capacitor is connected a neon bulb that lights up at 120 volts. And now you need to make sure that this capacitor accumulates so much charges across it or so much potential across it that it can light up the bulb. Okay, initially the potential difference across the capacitor is 0, so the bulb is not going to light up. Okay, and they are saying that there should be certain value of R so that the bulb can. It's like you are designing some sort of circuit, guys. So it can light up at 5 seconds. With a 5 seconds delay, as soon as you press that switch, it has to light up. And also do notice things like this. Given to you, log 10 is 2.5 is equal to log 10 2.5 is equal to 0.4. So these are the values given to you. First of all, we need to calculate. It's a calculation oriented question. So let's get started on this. And first of all, let's understand like what does this circuit look like. But anyway, guys, you must have perceived the circuit in your mind. That's what I'm guessing. Okay. So first let's draw the circuit. So there is going to be a capacitor and there is a resistor. Alright, assume these are the terminals of capacitor. You have this entire thing connected to a EMF source. This is your battery. Alright, and what is the rating? What is the voltage rating of the battery? It's 200 volts. Right? Which question? Initial questions are very generic question, guys. This is JEE Mains question. Hey Akash, this is JEE Mains question. This was, some 2000, I don't remember, 2012, 2015, JEE Mains question, something like that. So this is, 200 volts. And this capacity, you don't know the value of R yet. You have to design the circuit such that, this value of R, you have to determine the value of R such that it can light up at 5 seconds. Okay. Yes, of course. Actually, previous year questions, you solve it to understand the model problems. I mean, typically, you may not expect one such question again, but you can get a very similar model. Like what is being asked, like in this case, for you, the log, like 10, 2.5 is given to you, but log, all you get is a natural logarithm. So there are a few things that you need to remember. These kind of ideas you'll get once you do the PYQs. And also, like, what would be the difficulty level and how much time does it take you, something that you have to ask. And, there is a bulb. So this is the bulb which will only glow at 120 volts. Bulb that will glow at 120 volts. Alright. So this is the circuit, guys. I hope you got it. So for it to attain that 120 volts, capacitor first of all should attain 120 volts. They both are connected in parallel actually. Okay. So understand that maybe the circuit diagram is not given to you, but still you must be able to deduce the circuit diagram. All right. So that was, the entire just behind drawing this, circuit diagram. So the thing is, when it would reach 120 volts is the question. Okay. Only JEE, no, not only JEE. No notion. Of course, you have to do other kind of practice problems. JEE is just, previous year JEE problems, like let you know, like you have to remember a few things. This is how much time it takes, so I need to improve my timing, and also, something like, let's say, not only that, also like model problems. What kind of model problems are being asked? You're not going to get direct questions. So I told you, like RC, they're not going to ask you RC. RC was something that I asked you. Okay, once that graph becomes obvious in your syllabus, maybe they'll ask you some questions like that. Okay, so let's move on and understand. So it's basically an equation based question. You understood that it's a calculation intensive question, nothing more than that. So I'm just going to switch over and get started with the problem. So we need to do the this thing as calculation, and you can also understand, students, like which kind of problems take you a lot of time to solve and which kind of problems take you lesser time to solve. So if you remember this equation, Q is equal to Q naught, so I'm writing it as V is equal to V naught 1 minus e to the power t by tau. Okay, we have to calculate the tau. That is what we need to do, and we know it should light up at 5 seconds. So given to you are, this is how you get started every time in the beginning phases. T is equal to 5 seconds, and it should be like V is equal to 120 volts. This is what is supposed to happen, right? At 5th second, it should reach 120 volts. VC should reach 120 volts. Okay, and 120 is equal to 200 into 1 minus e to the power, let's for now keep it as 5 seconds by tau. Okay, we could have just kept it as t. So what is this giving you? This is giving you something like like 200 by 120. That is just, let's keep it as just 120 by 200. Sometimes it is convenient to keep it as that way, so that we don't have to put in much efforts while solving the problem. Okay, that being said, let's switch over. So we got this expression that 120 by 200 is equal to 1 minus e to the power 5 by tau. Now e to the power 5 by tau is how much? 1 minus 120 by 200, which is nothing but 80 by 200. Okay, 80 by 200 is how much? 2 by 5. All right. So take a natural logarithm on both sides. So you'd get this. But after applying log, after log, what do we get? Minus 5 by tau is equal to ln 2 by 5. And of course there is some use of this, we know that. So this implies tau is how much? 5 by ln 5 by 2, isn't it? So you can write this, right? This comes from here. We have something like this, any log, you can write it as ln b to the power a. That's what we did. You can inverse. Alright, this is how much? Tau is equal to 5 into, it's I'm going to erase all of them. Noted it down. So we got tau is equal to 5 into ln 5 by 2, which is nothing but 5 into ln 2.5. But this is base e. Given to us is some simplification in base to the power 10. So we need to first of all convert it into base e. How do we do that? You remember? Ln x is equal to 2.303. So do you remember, students? I generally don't recommend memorizing things, but there are a few things that you need to memorize, right? 2.303 into log 10 of x. All right. And that being said, okay, what am I doing over here? Should we not having this? Okay. That being said, this should be 5 into 2.303 into log 10 of 2.5. And how much is given to you? Log 10 of 2.5 is 0.4. 5 into 0.4, 2. 2 into 2.30. All right. And RC, tau is nothing but RC, right? Do you know this thing as well? Tau is equal to RC. We are going to do that. RC is equal to 2 into 2.30. 303. And what is your R and C? R is something that you have to find out. C is 2 microfarads. 2 into 2.30. Cancel out, 2 and 2. You have 1 microfarad. You carry it to the other side. What would be the value of R? You'd get R as something, do that as well. From these two, you'll get the value of R. R is going to be 2 point something into 10 to the power, like 1 by microfarad, right? 1 by microfarad means micro is how much? 10 to the power minus 6, so you get 10 to the power 6 ohms. So you need to have 2 into 10 to the power 6 ohms to make sure the bulb glows after 5 seconds, where the bulb can be lit only at 120 volts. As soon as the capacitor hits 120 volts, the bulb will glow. Alright, a very calculation intensive problem. So near about, I think 2.7, I think it should have been 2.7. So anyway, you can once check the conversion, guys. Check the conversion. But what is ln some x2? I think we have done it correct, but maybe it was 2.7. I wrote it down as 2.303. Let's move on to the next question. So this is a JEE advanced question. Notice this question very carefully. It's a very easy one, guys. So at time t is equal to 0. So this question has nothing very conceptual. Everything is given to you. This is the beauty of JEE advanced. So you will be given pretty much every information. Like you don't have to spend lots of time remembering things. All you need to spend time is understanding concepts and solving different kind of concepts. Never get confused about it. So 2 would get cancelled, right? Yes, RC is, yes, Ravishan, that is correct. RC's value is 2 into 2.303. And what is C? C is 2 microfarads. So there you would remove the 2 microfarads and take it to the denominator. 2 would get cancelled. And then 2.3 to 10 to the power 6, since it's microfarad. Right, Chandan, good question, sir. If any question is very bouncing, don't attempt it. If it is totally out of your concept, don't get surprised. Okay, if the question is lengthy, you know the concept, you can make use of some tricks to guess the question. Okay, let's try to like Krunal Chandan has asked the question. If any question is very bouncing, how to guess the answer? So it goes on the top of your head. The simple thing to do is forget it as far as JEE Mains and JEE Advanced are concerned, because you don't want to hit that negative mark. That negative marking will pull your rank down, guys. But there are some logical guesses that you can do in physics. Physics is actually totally full of concepts. That way, there are a few things that you can do to quickly solve it. Alright. So let's, for an example, we talked about 4 tau, 5 tau, and we solved few problems earlier in our resistor combination where we were deriving the power, and we use some guessing methods. But as such, you can't easily guess things. Like you should not just guess things. I mean, you can easily guess things, but you should not guess things randomly. Okay, at time t is equal to 0, a battery of 10 volts is connected across A and B. Okay, given to you this diagram, there is A and there is B, so there is B and there is A. So across A and B, you have connected a battery. The capacitors have no charge initially. At what time you would get 4 volts across them? Yes, you should live it, Kunal. That's the best thing. That's the best thing, guys. If you're not aware of the concept, let's say I haven't ever done any questions in inorganic chemistry, or if you haven't done any questions in let's say magnetism or something like that, forget it. Forget it. One is like you can do method of substitution. Even if you're aware of the expressions, you can work around method of substitution. So let's say I want to try and guess this question. Maybe let's try out and let's see if this is possible. So what are the options given to you? 1 second, 2 seconds, 4 seconds, 6.5 seconds. By the way, students, this was a numerical question. I brought up the options, but this was a numerical question, so you understood it should be 1, 2, 3, 4, and 5. So let's do a thing. Let's try to guess this numerical question and see if we are able to do something around it. Okay, let's try it out, Kunal. So the thing is, so let's try out Kunal's. So few things we have to remember, right? We can't just move on even without remembering anything. That would lead to faulty results. So it is told that this has to reach 4 volts and you have connected 10-volt battery. So first of all, you need to understand this is in parallel combination, alright, and this is also in parallel combination. So what is the R equivalent over here? R equivalent is, so you're connected across them. You're connected a battery across this circuit. So you are going to deduce R equivalent and start calculating things. And this is like a 10-volt battery, guys. Okay. So R equivalent in this case is 1 mega ohm, and in this case is 4 microfarad. Let's try out the method of guessing. Maybe in this case, this values are given to you. Method of guessing is lower. Okay. C is somewhere around 4 microfarads, parallel combination. So you have C equivalent, that is going to be 4 microfarads. The potential drop across them, is going to be 4 volts, be it 4 microfarads or 2 microfarads, 2 microfarads in parallel. All right. And then what do you have? You have like R equivalent as 1 mega ohm. All right. So that being said, what would happen at when you have to reach 4 volts from So okay, I should not be moving so fast because many of you are just getting started with the concepts. So yes, that being said, guys, you go through this equation. Vc is equal to V naught. Same thing. Q is equal to Q naught. 1 minus e to the power t by tau. This is some expression that you have to remember. I told you in the beginning itself, but you have to know how this comes. How to, given any situation, you should be able to, understand this concept. Okay, all we did is we took the equivalent. Okay, this is what we did. We took the equivalent, and then we proceeded saying that this 4 volt will appear across the capacitors, irrespective of this 2 microfarad capacitor in parallel combination or 4 microfarad capacitor. That being said, we know the value of RC as well. I don't think guessing would work in this question though. Let's see. Yeah, I think guessing won't work in this question. You can, you have, like, so 4 volts, and this should be 10 volts. And yes, you can actually come on to, Unacademy learning app, or you can come on to YouTube every day and you can ask your doubts. That should not be a problem. And okay, let's try out another question. Kunal. This question, I don't think method of guessing. Maybe the next question it will work. Okay, so let's start from the beginning because this is a numerical based question. We should not do that. And so the thing is really simple. We are going to take the R equivalent. So let's do that in the next question. Okay. I thought we can do some guessing around this. That won't work, Kunal. So this is 4 microfarads, and this is going to be R equivalent is 1 ohm, 1 mega ohm. So C is over here as 4 microfarads, and R is 1 mega ohm. Okay. Yeah, let's do that in the next question because this question is supposed to be, actually simpler than guessing it. Because if you notice that there's nothing but Vc is equal to V naught, which is nothing but Q is equal to Q naught, 1 minus anomaly of that, analogous to that. So Vc is equal to V naught into 1 minus e to the power t by tau. And that being said, you need to reach 4 volts. That is what is told to you. And you are given that the battery is of 10 volts. So that is the maximum potential that can appear across this capacitors once they reach the steady state. And 1 minus e to the power. And what do you have? You have only value of tau. Tau is how much? 1 mega into 4 micro. So 10 to the power minus 6, 10 to the power 6. I'm going to directly write it down as 4 seconds. Okay. For 4 seconds, it is going to be 63%. Okay. All right. Okay, we can guess it from there as well, right? So yes. So they're asking you when it is going to attain 40%. Okay, let's do that just for you. But yes, Ananta Krishna. Yes. Yeah, you can communicate over here, Roshan. So yes, Kunal, coming to your query, how do we guess the questions from the answers? So one thing you know is R equivalent, and we just calculated R equivalent, and so it's if it's a multiple option question, you are going to do that. Else you can't do this in this case, right? So tau is RC, and we calculated R equivalent was like 1 mega ohm for this both, and for this both C equivalent is 4 microfarads. Okay, so that is going to be 4 into 4 microfarads. So you know that at tau it's going to be 60. So this is the method of logical guessing, guys. So this is going to be 4 seconds. At time t is equal to like tau 4 seconds. It should be 63% charged, or 63% potential should appear across it, isn't it? Then your answer has to be less than 4 seconds. So C is not the answer, D is not the answer. You have to assess between 1 and 2. But if you write down the equation, you very well over here itself, you understood it is not 1. Okay, calculated if it was 1, then we hadn't been, this should have been like equated somewhere. So 1, and one more thing is this is 40%, near about 40% of what it was originally. So that way, sure, Ocean will do something. Okay, we actually have, we can get on to JEE English Telegram channel later on. We'll facilitate the communication. Okay. Okay, this is something that you can do. I hope you got the point. So as soon as you approach this point, so one is at tau it should be 63%. Tau is 4 seconds, so it should not be C and D. Method of elimination, it will not be 1 second, guys, because if it is 4 seconds, at 1/4 of tau it is only probably charged little more than 35% and odd. Maybe at half of tau it reaches 40%. So that should be like B. Okay, so this is one of the ways of doing it, but it's actually a numerical based question, guys, so don't do that. You need to properly go through the calculation, and even values have been given for us to simplify this answer. Okay, it's 2 by 5 is equal to e to the power t by 4. All right. Yes, Roshan, get on to our Telegram channel, JEE English Telegram channel. Maybe we'll facilitate this, doubt sessions or some live interactive sessions for you guys. So we have until here. What am I going to do is I'm going to, take 1 minus 2 by 5. I'm just writing it down as e to the power t by tau. I haven't yet substituted the value of tau. Tau was like 4 seconds. We have substituted over here. But yes, we have substituted, but not over here. Okay, 3 by 5. So now it is nothing but like tau's value I'm substituting now. 4t by 4 is equal to ln 5 minus. So this was actually a very simple problem, right? Even than your JEE Mains problem, JEE Advanced problem is simpler. That's what I told you guys. It's only a very conceptual problem. You need to understand that the voltage that would appear across these two microfarad capacitors in parallel is the same as 4 microfarad in series of the mega ohms in parallel. Okay, so that was the concept. That's it. The concept, if you are understood, the calculation is very minimum. So there you have an advantage of JEE Advanced, and I often keep telling the students that in JEE Advanced you're probably spoon fed with everything that you need, but at the same time you're left confused somewhere. So it's 50% of the time is where it would of tau is where it would reach. So we know that t is equal to, this is 0.5, 1.6. This value is given to you. Always make use of this values. This is given to you for some reason to simplify your calculation. That should be 2 seconds. Amazing, isn't it? Very easy. So you could have guessed it as well. At 1 second, it would be 1/4 of tau. We saw. Okay, and one more thing you saw on the graph is at around it reaches 0.5 volts, 0.5 of the maximum at near about 0.7 tau. At 0.7 tau, it reaches anywhere around 50% of the maximum. So 5 volts would be reached at somewhere near 0.7 times tau. So that was 3.2 seconds. So you can guess some things like that. But yes, this is one of the ways of doing it. But this was actually, as I told you, it's a numerical based question. You have to answer in terms of numbers. Okay. So yes, let's again try out Kunal's query. Yeah, our guess was correct. Yes. So again, let's do that thing, guessing, but we have to understand concept, guys. Just this one question, we'll do the guessing, not for rest of them. First of all, whether we need to see whether this question is guessable. So combination of two ideal capacitors, one a resistor of like a resistor R and a DC voltage of 6 volts is used in a CR experiment. It is found that for a parallel combination of two identical capacitors, so there are two capacitors, and for the parallel combination of the capacitor, the time in which the voltage reaches half its maximum value is 10 seconds. For series, the time needed for the series combination to reach half its voltage. So what is being told to you is there are two capacitors, okay, identical capacitors, and you have a 6-volt battery and a resistor R. Okay. So now what they are doing is initially they analyzed it for the parallel combination of the capacitors, and they found out that in at the 10th second it reaches near about it reaches half of its maximum voltage. Okay, it reaches half of its maximum voltage, and they're asking you if it was in a series combination, then what would happen. Okay, let's take a couple of seconds to understand this question, and then we'll guess it, and then we'll move into the actual way of doing this. Like this question. Okay, so what they have given you is one 6-volt battery, and there is a resistor R, and there is a parallel combination of capacitors, just like what we did in the earlier problem. Okay, parallel combination of capacitors. Oh, this is clear. Time required to charge it to the half. Yes, to the half. What do you think should be the answer? Hi Rehan, hi, a very warm welcome guys, and stay focused on the class. So yes, this is the initial thing given to you. Hi Rehan, hi. So that being said, this is C and C. So this is the first combination given to you, and in that combination it is said that it takes 10 seconds to reach D by 2, reach half its voltage. Okay, let's erase everything. To reach half, 10 seconds. Skim through the question in your exams. Now, the second combination is 1. No, not B. Work around this. At least, guys, try to do the logical guessing. We just did a very similar problem, and actually, logical guessing is possible in this case. Okay. And that being said, there is one more combination in this. What is happening is you have capacitor C and C in series. Okay. Capacitor C and C in series. This is 6 volts again. This is C and C. Now they are asking you to reach D by 2. How much time is it going to take? What is the time? No, it should be more than or it should be less than. So one thing, let me ask you a thing. So what is the effective capacitance over here? I'm going to calculate the time constant for the circuit. What is the C? C by 2. And what should be the C over here? Should be 2C. Guys, when you're doing logical guessing, make sure your first guess is correct, else the entire thing will go wrong. What about the tau over here? Tau is how much? 2 RC. How about tau in this case? And what is tau, guys? In this case, tau is RC by 2. That's correct, yes. In this case, tau is RC by 2. So that means this reaches 63% faster than this thing of parallel combination, isn't it? It's also logical because there are two capacitors across which you have to deliver V and V potential, or 6 volts and 6 volts. Whereas in this you have to only give them 3 and 3 volts and they will reach almost the steady state, isn't it? So should it be more than 10 seconds, or should it be less than 10 seconds? So this takes longer and this takes shorter. Yes, right. So what it should be? Should it be more than more than 10 seconds, or it should be less than 10 seconds? It should be less than 10 seconds, guys. Okay, it's V by 2. Here we have already calculated for 63%, and it's literally 1/4 that value. So we're going to call this as tau 1, and this as tau okay, this as tau 1, and this as tau 2. So there was 10 seconds, 20 seconds, 5 seconds, and 2.5 seconds, I guess. What should be the answer, Kunal, in this case? To reach 63%, okay, to reach 63%, this one takes RC by 2, as this one takes 2 RC. This is longer, isn't it? This is longer, guys. Okay, so what is the value of tau 1 by tau 2? Yes, that's correct, Kunal. That's it. Yes, that is correct. We'll derive that part. Don't worry about it. We'll anyway derive it. There should not be any confusion in that. So we'll do that as well. Tau 1 by tau 2 is how much? Like 1/4. So within that 1/4 time of what this circuit takes, this would be charged faster than that. This will literally take only 1/4 time. Yes, that's correct, students. Yes, that's correct, Ryan. That's correct. It will only take 1/4 of that time. Okay, but this was about tau, guys. We should not be doing it this way, but at the end you will get the same kind of expression. Don't worry about it. So initially, it's little mathematical, not very mathematical. I think this was also JEE Advanced. I wrote it as JEE Mains, I guess. I don't know whether it is JEE Mains or JEE Advanced, but anyway. So in the first case, let's go for the parallel combination. We know that I'm talking about just the parallel combination. We are going to calculate half the voltage. So the condition is it's V by 2. Okay, it has reached V naught by 2. And in how much seconds? Given to you is in 10 seconds. Because this will not work all the time, maybe. Or would it? Let's check it out. Let's check it out whether what we are claiming is correct or not. And we know that C equivalent is 2C in parallel combination. R remains R. Okay, so we don't care about it. And so that means tau is, let's call this as tau 1. Tau 1 is 2RC. Alright. And Vc is equal to V naught into 1 minus e to the power minus t by tau. And that being said, what is Vc? Vc is V naught by 2, and this is V naught. And this is V naught. This is 1 minus e to the power t by. Alright, alright, and that is 1 by 2, that is like v naught minus so 1 minus this is going to be 1 minus 1 by 2, that is going to be 1 by 2 e to the power t by tau thing, but 1 by. Alright guys, so that being said, how much is this? So we know something known as e to the power some 10 seconds by 2 RC is 1 by 2. We have this answer. We have some expression like this. We have another page. So this is for parallel combination. From this you need to note down this thing, e to the power minus 10 by 2 RC is equal to 1 by. That is it, students. That is it. Now moving forward, what will we do is we will be deriving for series. For series, you know few things. C equivalent, we don't know time. Time is something that we have to find out. All we know is C equivalent and tau. How much is C equivalent? C by 2. Alright. And how much is tau? Tau is RC by 2. Isn't it, students? Yes. So let's call this as tau 2 for now. And what is the time taken for it to reach? V naught is the question. Okay, V naught by 2. Okay, when does it reach? V naught by 2. This is being asked, isn't it? So let's analyze this part and let's come to like a conclusion, like whether what we had derived and what we had guessed is correct. We guessed it within few seconds, but yes, if you are doing it in pen and paper, it's going to take only few seconds, guys, without any explanation. Move very quickly. It's only few seconds problem, isn't it? So that means now we know that V naught Vc is equal to V naught into 1 minus e to the power t by tau 2 in this case. So what we are going to do, we are going to substitute Vc is equal to V naught by 2 and equal to V naught into e to the power minus t by Rc by 2. Okay. So this cancels out and we get something like no 1 by 2 is equal to e to the power minus 2t by Rc. Okay, so time is equal to, I'm taking logarithm and directly writing it down, guys. Okay, Rc by 2 into ln 2. This is going to be the time for t2. And what about t1? T1 we know the value. We are not going to write it down as t1. But let's calculate this value and bring out the value of Rc. That is what we should have done in the first one. So from here we know that that's going to be ln 2 and that's going to be ln Rc is equal to so this can be 5 by ln 2. From here we know that Rc is equal to 5 by ln 2, natural log of 2. Substitute it and you will get the value of t2. How much did it come out to be? 2.5 seconds. Really what we started with. No. So if I substitute Rc, then we would get T2 is equal to 5 by ln2, substitute RC, this term over here, into ln2 by 5 by 2. So T2 came out to be 2.5 seconds. You guessed it quicker, but would that be true for everything? Yes, that would be true for any time. Okay, because we know the value of RC. Okay, there the difference is it's going to be 1 by 4th of anything that you're going to calculate, isn't it? Because V naught by 2 is given to you. Even they are asked you how much time it takes for it to reach V naught by 4, you can calculate. Okay, pretty much the value is sort of given to you, like how to do this. So that means the answer should be D, 2.5 seconds. Alright, let's do a thing. So I guess it's already time, guys. So we'll get started with the discharging of capacitors in the next upcoming session. And we'll also deal with something very interesting known as, combination of resistors. So we have more IIT JEE Mains and IIT JEE advanced questions. We'll be also dealing with few more questions in the next session. And that being said, guys, go through the session, complete it. Then we'll derive for this discharging capacitor, and also we'll solve very interesting problems around them. What if you had multiple resistors? Some problems like this. Okay, we'll be solving. So if you have some time, just note down this problem and try to solve it. Try to find out the time constant of the capacitor in this case. So this is a very interesting problem, students. Actually, do it in the way we derived. So today we spoke entirely about deriving it, right? So try to derive it using that method. Okay, try to derive it. Discharging is going to be super easy. It's hardly going to take 10 to 15 seconds, 10 to 15 minutes to complete it. But yes, this is the interesting part. And come up with some analogy for your derivations. Okay, try to note down the circuit and try to derive the time constant of the capacitor in this case. And it will be very interesting. You'll find out really something interesting in this case. So do that. And let's see you in the next session, and stay tuned, stay updated, and complete all your sessions on your capacitors and current electricity. And do not forget to share this video, share this channel, like this video and like this channel. And that being said, guys, knowledge does not come from, power does not come from the knowledge cup, but comes from the knowledge share. So share the knowledge, don't keep it to yourself, share it, guys. And you never know if some student who's in need of an awesome channel where they can learn from the basics until your advanced level can do that on this channel. And guys, it's the first channel by Unacademy where we deliver every content for JEE preparation exclusively and completely in English. And that being said, it is also the nation's first channel where you are getting all the basic concepts to the advanced concept for your JEE preparation. And guys, right now Unacademy is impacting near about 7 million lives a day. So I hope you're one among them. Maybe it's anywhere around 10 million lives a day. We never know that. So make sure it happens. You and Unacademy and yourself are able to impact more and more lives a day. You are a part and parcel of this entire process. So make sure you share the channel, click on that subscribe button and bell notification to get timely updates on many such awesome sessions where we'll be solving and learning many interesting concepts. And that being said, guys, do not forget to click on that like button and do share it on all possible social media, be it your Telegram channel, be it your WhatsApp, or be it your Facebook. And to students to understand, get all the timely updates on what is happening on our channel, click on to this link available in the description box below. And guys, you can just type in JE_English to find us. And if not, you can just click onto that link available in the description box. First of all, you need to download the Telegram app. Okay, and that being said, students, we have already completed an awesome session on color coding of resistors on Unacademy learning app. So do visit this lecture. It's an awesome lecture. It's a very easy, very short lecture, but at the same time, there were anywhere around 5 questions combined in your JEE Mains 2019 session. very easy questions, like hardly 20 seconds question, but at the same time, like literally they asked you what is this value of resistor. So complete this session. Do not forget to complete this session. It was conducted on 31st of August. It was a free special class. You need to download an Academy learning app to attend many such free special classes. All you need to do is like type in an Academy in your Google Play Store and App Store, and your first and the foremost result is going to be an Academy learning app. And click on that install button, and there you go, you will get the app to attend many such lectures. And not only that, if you are already on the subscription platform, it would be very useful for you. And guys, we have an awesome complete package for your JEE preparation. How to avail that package? You need to click on to this extension bar, and there would be your first icon that you choose, and then you would choose your goal as IIT JEE, and you will get your subscription. And students, that being said, you know what? You get everything that you need for your JEE preparation on the single platform. The state-of-the-art technology that simulates the environment like you have in your exams, and not only that, it comes with all the features that is required for improving you every day. And what all comes with this? Live test series, time test series, like how you should do it and how you should practice and prepare for your JEE Mains and JEE Advanced, and all the lectures from the basics until the depth in a very systematic and in a program based manner. You have many batches going on, anywhere around 80 batches right now going on Unacademy learning platform just for your JEE preparation. And it also comes with other perks and benefits, like having leaderboards and dashboards where you get to understand your standing, and not only that, you get your personalized insights to improve yourself every day. And your live quizzes and live tests, the series also comes along with it, as you know, but you also get to learn from your favorite educator and also get your doubts cleared from them. And guys, it's only one subscription and unlimited access for that period. But that being said, guys, the prices are on hike from 10th of September. So try to avail it as soon as possible and apply the Murli Live coupon to get the 10% instant discount. Hurry up, students, especially 11th standard students. Don't miss it out. The 2-year long journey, if you avail it now, it's going to be super economical. And that being said, the prices right now for 2-year subscription is anywhere around 32,400 even after you apply Murli Live coupon. So it's pretty economical. After you apply Murli Live coupon, it's very economical, but later on it's going to be anywhere around 50,400 even after you apply Murli Live coupon. So it is going to be hiked by anywhere around 32,000. So it's going to be hiked by anywhere around 18,000. So avail it as soon as possible. Don't delay on the students. And that being said, right now the prices are low, the prices are slashed. So check it out. Like it's anywhere near about 5,000 rupees for a 2-year subscription, and 1,500 rupees per month for a 2-year subscription. You can apply Murli Live coupon to get a 10% instant discount on this purchase. So if you apply this coupon, you'll get 10% on this package. Not forget to apply the 10% coupon on your purchase. And guys, we have 6,000 plus materials for your JEE preparation alone. And guys, do remember, it is the India's leading and the largest test preparation platform, and we have the best educators on this platform. And not only that, we have awesome authors and popular authors the books that you go through, like DC Pandey sir on this platform. And students who are in long term and dropout, you may want to get into the 1-year subscription if you're only looking for 1-year thing. But 9th class and 10th class and 11th class students, don't do that, because it's a 2-year long journey. So try to get a 2-year subscription that is going to cost you even less, and after the coupon it's going to be very economical. It's going to only cost you as much as it takes you to travel to any places. And I mean, like for your daily travel, that is how much you would spend on it. And that being said, 2,500 is near about 2,500 is how much a 1-year subscription is going to cost you, near about more than 1.5 times. That's the reason I say, if you are really going to prepare for 2 years, get the 2-year subscription. And if you think this is expensive, students who are going to avail the 1-year subscription, apply the Murli Live coupon, you would get a 10% instant discount on your purchase. And that being said, students, see you in the next session with more awesome concepts. Tomorrow we have a lecture on vectors, and we'll be also dealing with more of capacitors, so don't worry about it. So see you in the next session. Take care, stay safe, bye-bye.